show. 47.
All right.
I don't have to.
Did everybody have a good long weekend?
No,
No.
it was sad. It was like the whole weekend.
I like Brian.
Yeah, but you weren't here.
I mean, besides that, yeah.
All right. Yeah, it was a little chill. You like rain? What's the matter with you?
A lot.
All right, any questions on what we've done so far? Remember, this whole unit's all about construction. So we talked about constructing inscribed squares, constructing inscribed hexagons, constructing inscribed equilateral triangles, and drawing lines of reflection. Yeah,
So when is our test for this?
Monday and Tuesday.
Okay. 2 days?
I mean, Monday.
Okay.
Monday, sorry. Okay. All right. So, and also this week, I'm not gonna be here Friday. I have a doctor's appointment thing. So, it's really just gonna be Wednesday and Thursday new material, and then the testing is Monday. Okay, I thought about making a video or something with other stuff, but
Do you have any new material after that?
no, we're gonna talk about the Regents exam, even though we're not having it, but we're gonna talk about that for the rest of next week, and then it's the final exam, and that's it. Okay? All right. So today we're gonna talk about constructing a reflected triangle, which is not quite the same thing as constructing a line of reflection, but it's similar in the theory behind it. Okay, so this is constructing a reflected triangle. So for these problems, they're going to give you a triangle and then a line to reflect over. And you just have to construct the reflected triangle, the image triangle. Okay? So like, for example, my ruler device here. Let's make the original triangle be like, and have this triangle. I don't want to make it vertical looking because this smartboard has a hard time having things that are almost vertical but not quite. Okay, so suppose you have this triangle. Let's label vertices ABC. And let's have a line of reflection. And again, I don't really want to make it almost vertical. So or horizontal, just draw it diagonal, like that. And let's call this line L. So the instructions would be to construct the image of triangle ABC after a reflection over line L. Okay, so construct the image of triangle ABC after a reflection over line L. Okay, so you can sort of vision what the image would look like. It's just going to be a triangle that's like over here somewhere, right? Everybody can envision that. I don't know what that looks like. But as always, if you just drew a triangle over here that kind of looks okay, it's there with no markings, you get no credit, right? So if you remember how we constructed the line of reflection the day before break, that construction was with the understanding that the line of reflection is perpendicular to the line that connects a point and its image. Does that make sense? So essentially what we're going to do is we're going to like take this point, construct a perpendicular line that goes across line L, and then like copy that distance and this distance to get A prime. Does that make sense? And then we're going to do the same thing to get C prime. And then theoretically, we could do the same thing to get B prime, but there's a way of finding B prime with less work. Does everybody understand what I'm saying? So I'm going to construct a perpendicular line that goes through A and is perpendicular to L. And I'm going to draw that line, and then I'm going to make sure that this distance from A to L is the same as the distance over here from A prime to L. Okay, so for this, I'll do it in green. Okay, so step one is to construct the line. By the way, this construction is probably the most involved construction that we've done so far, that has the most work. Okay, so construct the line perpendicular to L and passing through A. Okay, so you got to remember how that construction works. That was one of our basic constructions. It wasn't one of the basic constructions, but it was one of the constructions we talked about when we talked about parallel and perpendicular lines. Okay, so that construction goes like this. The first step is to create a line segment down here on line L where A is directly above the midpoint. And the way to do that is to put the point of your compass at A and open your compass wide enough so that it intersects L twice. So you got to go like past line L, and you just have to make sure it goes through it twice. So I'm going to make an arc like this that intersects L twice. But essentially what you've done is you've created a line segment, this little piece of line L right here, a line segment in which the midpoint of that line segment is directly below A, perpendicularly. So now all we're going to do is take this little line segment, this piece of L, and do the perpendicular bisector of that. So I'm going to put the point of the compass at that one end point and open it more than halfway and make an arc. Now, remember, I don't necessarily have to do the entire arc. Like, I'm going to do this entire arc like that, but I don't necessarily have to because I have point A that I can use as like an anchor point. I really only need one of these intersections between arcs. Okay, but I'm just going to draw them all just because better to have too many markings than too few markings. But if you watch the Delta Math video, you'll see that they just do like this part of it. They'll do like the part of it up here and the part of it right here. And that's the only part of it they draw. Because really, that's all you need if you think about you have point A to connect to that point, which then will be perpendicular. Does that make sense? So you could do it with a little bit less markings. And I'll just leave it like that. Now I'm just going to connect point A. Well, actually, I could just connect here, but I'm going to connect point A. Thought I had my ruler thing drawn. Go to my ruler thing. And I'm just going to draw that line that goes through. Line that goes through A and also through those 2 points. So that's the perpendicular line that goes through A. That's step one. Okay, step two is to copy this distance from A to L, and then copy it over to here to go from L to A prime. Because we know that not only does the image of A have to go perpendicularly to L, it also has to go across it the same distance, right? So that's step 2. Step 2 is to copy the distance from A to L to get the location of A prime. Okay, so I'm going to my compass. Remember, you can't use your ruler to measure. So I'm going to use my compass to measure this distance. Right, I'm measuring that distance, and then all I need to do is just keep the point at the same point on L and just go over and copy it to there. Okay, now it's definitely true that A to the line is the same distance as from the line to that point. That's the point A prime. That's the image of A. I'm a third of the way there. Told you this one's the most work. The next step is to just repeat that process with point C. Now, I'm not going to repeat that process for point B because it'll get a little bit messy since B, to get from B to the line, you got to like go through the interior of the triangle. It makes it a little bit harder to follow what you're doing. So I'm going to repeat the process for C because that's the other point that's close to L. Okay? That's step 3. Is to repeat steps 1 and 2 for C. Okay, so that process was, steps 1 and 2 were, we take the compass, put the point of the compass at C, make sure the compass is open wide enough that it will intersect the line twice, and draw that arc. That, right? Then I'm gonna do the perpendicular bisector of that little piece of L. So I'm going to open my compass more than halfway, the end point, or with the compass open, sorry, with the point of the compass at one of the end points. Make an arc. Flip it around. Make another arc. I feel like it's hard to work with instructions when you have such a small thing to do, but it's close enough. And then draw the line that goes through it again. And mine looks a little off because it's so small. But generally, make sure it doesn't look too horrible, or it's not right. Remember, constructions are drawn to scale. So if yours looks bad, then it's probably not right. Oops. All right, then I'm going to copy this distance again. Flip my compass around. This is looking a little sketchy. All right, so now this is the point C prime. So I can connect A prime and C prime, and I have one segment of my triangle done. So that point, so that segment right there is A prime to C prime. Now I could, if I wanted to, it would be full credit to do the same process again to B. That's kind of a lot of work. So instead what you can do is you can just copy this distance and this distance to get the location of B. All right, so let me actually do it, then I'll write the instructions. Okay, so the process is to measure the distance from A to B. Okay, measure the distance from A to B. And remember, you got to make a little marking to indicate that you've done that measurement. And then come down here and mark that distance kind of out here in space where it should be. And then I'm just going to copy the distance from B to C in the same way. This. From B to C, and then come down here, do the same thing. And where those two arcs intersect, that point is the correct distance away from C prime to get B prime, and it's also the correct distance away from A prime to get B prime. That point right there has to be B prime. So when I draw it in, it should look pretty good. If I connect that to there, that to there. That's my final triangle. Okay, so how do I explain that in step 4? Step 4 is to copy segments A, B, and CB to get the correct location of B prime. That's all I'm doing. So copy segments A, B, and CB to get the correct location of B prime. That's quite a construction. It's a lot of work. Let's try it one more time. But this time I'll use Delta Math just so you can kind of see it'll look a little less messy. Delta Math. This is one example where I think that that's true. I don't think that's true generally for other constructions, but for this one, there's so much to it that I think it's easier with Delta Math. Right, so here we go. All right, so here's the problem. So first I'm gonna draw a perpendicular line from R to the line of reflection. So I go my compass, open it enough that it's going to intersect the line twice, make an arc here, and make an arc here. Now I could, make an arc here. I could have done the whole thing, but really, I could have done this, that's okay. But really all I need is like that point and that point, right? Then I'm going to move my compass to that endpoint, make sure my compass is open more than halfway, and make an arc. Move it to the other endpoint over here, and make the same size arc. And then just connect the dots. So I could do it with a line or a segment or array, it really doesn't matter. I'll do a line. And you'll see that that line should go right through R, which it does. Then I'm going to use my compass centered at that point and go to R and make sure that this distance is the same as this distance. So now I have R prime, goes right there. Now I'm just going to do the same thing at P. Open the compass enough that it intersects twice in arc. Then do the perpendicular bisector construction. Connect those dots. You can see that goes right through P. Copy the distance. Oh, good job. So now I have one segment right here, here, there. The only thing left to do is to copy RQ and PQ over to here. Oh, compass, RQ. Measure it. Go over here. Measure it. Do the same thing for PQ. Any questions on how I cut any part of that? Yeah, what's up?
I'm confused about the last step.
Okay, the last step, once you have this first blue segment, all I'm doing is I'm just measuring this, and where they intersect, that has to be where Q is. So I measure this, and copy it, measure this, and copy it, and that's it. That make sense? Okay, I'll help you in just a second. Let me make sure this is submit. Yeah, okay. All right, I'll come around and help people with it. I'm just going to stop recording.